For 1 second, I would love for you guys to close your eyes and imagine a color that you have never seen before. It's hard, isn't it? And the reason why that is because as humans, we only have 3 color channels, red, green, and blue. But the mantis shrimp over here has 12, which means that it can see colors that we can never even imagine. Why is that? Why is it that some animals get these superpowers, but others don't? Now, this is not a new question. Scientists have talked about this for hundreds and hundreds of years. And even Charles Darwin, the scientist who theorized and formulated evolution, had the hardest time explaining the evolution of eyes. But in 2024, we actually know a lot more. We know the building blocks of this whole movie. And this movie of evolution started 500 million years ago, from cyanobacteria, the building blocks to life. But we kind of know how it started, and we know how it's playing out today, with a diverse set of eyes. But what we don't know is what happened in the middle. Evolutionary biologists and scientists have tried to piece together this movie by using fossils, present-day species, which serve as snapshots of our evolutionary movie. But there's a problem. Fossils are only 1% of all species. So how can we try to create this movie using artificial intelligence? Can AI fill the gaps of this movie? One way I like to think about this is that we are only working with 1/100th of the data. Now imagine trying to fill in all these gaps. I postulate that we can do better. We can not only fill these gaps, but we can recreate the whole of natural evolution in computation. So let's start with the building blocks. So biologists tell us that there are kind of 2 aspects to the biological building blocks: the eye building block and the brain building block. What we created were computational replicas of these 2 building blocks, the artificial eye and the artificial brain. Now we can take these artificial eyes and brain and simulate what a bacteria would see 500 million years ago computationally. And what the bacteria sees is not much. It's kind of light sensitive, which is what we expect, because these are really the building blocks to eyes and brains. But let's now try to evolve them in a similar way as biology does. So we can evolve the eye component and the brain component, co-evolving these 2. And what we get after many, many hours of evolution is first signs of artificial vision. And this is a much clearer picture. We can see kind of the eye, we can see kind of the sky on the top, followed by some sense of environment. But let's continue simulating this evolution forward. So simulating this forward, what we start to get slowly is we get first signs of insect vision. And what we essentially start to do now is computationally recreate millions of years of evolution in GPU hours. Why is this important? So we're trying to understand we're trying to create not only artificial intelligence, but also understand natural intelligence. And instead of studying natural life, what we can now do is we can simulate it and study it, as well as using kind of the old techniques of studying life naturally. So, and I postulate that because we are co-evolving artificial eyes and artificial brain, we can study aspects that we were not able to study before. But let's go further. Can we simulate things that have not happened yet? Can we simulate what happens to our own eyes and own brains when climate change occurs, or to entire species when deforestation occurs, or even a mass extinction event? And can we go even further and start to simulate things that are impossible, such as what a human would look like if they had mantis shrimp eyes, or what would a mantis shrimp look like on Mars. Thank you.